I'm Joe Rogers. I'm with the Office of the Fire Marshal. I look after plumbing, building, and energy codes. I do have a colleague that looks after fire codes, but I know none of you are interested in that. So we'll just get right on to what I'm going to talk about, which is primarily where we are in adoption of the 2020 NECB. Before I get into that, for those of you who want to keep up to date on codes, we do run a mailing list called NS Code. So anytime we go out for public review, any changes to the national, etc., we send it out to the public. Right now, if you're not aware, there is 2025 codes. I know it's weird to talk about it, but there is a public review for the national code system ongoing right now till middle of December. And we send out those notices on NS Code. So I'm going to talk about the codes in general, both the energy code and the building code, and I will concentrate a little more on the NECB. So I think what's really important is to figure out where we are now. So the regulation was drafted back in August. We do what's called public notice. So we're required to put that regulation out for 45 days and solicit comments from people. We've received about 70 comments. 2/3 of them had to do with energy codes, ranging from great work, why is this needed, to we need Tier 4 now. So there was a lot of different comments out there. The comments are being reviewed currently with the idea of making a recommendation. Obviously, this is a ministerial regulation, so it is really up to the minister to decide. We can present options to him, but ultimately it's up to him. Once the minister approves the regulation in whatever form that takes, it gets published in the Royal Gazette and usually becomes effective at a future date. That's what we like to do. There are 3 ways of bringing it in. One is once he signs it, which really isn't fair to anybody. 2 is once it's published, which again, really isn't fair. So traditionally we set it off on a future date. And when we did go out for public notice, we indicated that January 1, 2024 was the anticipated date. So some of the most important things about the 2020 codes is it introduces the tiered energy codes. For 936, for those of you who are involved in housing, Tier 1 is essentially the current code. Outside of the introduction to the tiers, the changes that occurred are extremely minimal. And it offers prescriptive paths for Tier 1 and 2. In the national code, Tiers 2 to 5 use what's called energy compliance points. And what's important to remember is the Tier 1 in the 2020 codes is the base level. All future codes will be measured off of that level. Same thing with the NECB, it introduced the tiers. With the NECB though, there is only a prescriptive compliance path for Tier 1. For Tiers 2 to 4, you must use energy modeling. And it sets, again, Tier 1 will set the base level for all future codes. And Tier 1 is approximately 10% better than the 2017 codes. And where I come up with the 10% is we did do a bunch of modeling to try and figure out the implications. So some of the things we came up with for using Halifax, I can make these slides available to people, so don't have to take pictures if you don't want. So high-rise apartments, we found generally there's no change. Large office buildings, medium office, about a 10%. Strip malls, a little bit better, about 11.5%. Schools were a big improvement, about 30%, and warehouses were down around 5%. When we sort of looked at it, I just used the figure, it's about 10% in general, makes it easier, but as you can see, depending on the archetype of the building, obviously, different rules affect different buildings. So, next is on the tiers, what are they and when do they become law? That's the predominant question I get asked. And this is based on the public notice that we did in September. and may be subject to change. We did get some comments back, too much, too fast, or we're on the right track, but we need more time for education and to figure this out. So the regulations are expected to be published in the Gazette mid to late November. So for the building code 936, the tiers, tier 2 is about 10%, tier 3 is about 20%, tier 4 is about 40%, and tier 5 is about 70%. And I say that because it's dependent on path. There is this thing called energy conservation points. And while for tier 2 you need 10 points, depending on the path chosen, 1 point doesn't always equal 1%. So it's important to remember that. That's why I use about that. If you're doing modeling, you have to show a 10, 20, 40, 70% improvement. But the prescriptive path, as always, there's trade-offs involved. And one thing we did in Nova Scotia to try and expedite is only tier 2 in the NECB has 10 points. We made tier 3 20 points. To Nova Scotia variation. Right now, there are a couple of other provinces that are also looking at using the 20 points, but they have not made that official. When we went out for our public notice, we said that's what we're doing. Right now, we're looking at hoping that National has all the energy conservation points figured out for the 2025 codes, and then we will just move and adopt whatever they do. For the NECB, again, tier 1 is your prescriptive code. Tier 2 is 25% better. Tier 3, 50. Tier 4, 60. And that's modeling using part 10. So when we went out for public notice, these were the dates that we proposed. Just bear in mind, we could never bring in a code earlier than this without redoing public notice. But we do have leniency to bring it in at a later date. So, but what we went out with was January 1, 2024 to bring in tier 1 for both National Building Code and NECB. The building code, after that, will jump a tier every year. So tier 2 on 2025, tier 3 on 2026. And that's mostly due to a lot of the incentive programs. A lot of builders, especially around Halifax, are already building better than code, and their customers expect that. The NECB, we're looking at 2026 and 2028 for tier 2 and tier 3. And that's to give industry a heads up and say, look, if you're designing a building that's going to be 2 years in the making, you know what tier you're working towards. Tier 2 and tier 3, as I mentioned earlier in the NECB, you have to model it. Some of the things we did as a result of our modeling, we felt tier 1 and 2 should be readily achievable regardless of building code or energy code. So should be fairly easy. Tier 3 required a little more comprehensive approach and a lot more upgrades, particularly for equipment. And tier 4 in the NECB had to go heat pumps, had to go electrification, otherwise you really couldn't get there. But one of our main concerns is in the NECB, heat pumps and the rules around modeling them really need to be clarified, because heat pumps are considered not equivalent to electrical, but its own heat source. So when you model your tier 1 building with heat pumps, it gets very difficult to get that much of an improvement on a tier 4 building. Again, tiers 1 to 3, non-heat pump technology could generally be used, especially in places like Halifax where there is a natural gas network. There's also limited credit for heat pump hot water tanks, hot water heaters. And the one thing we didn't really dig into as a result, we didn't really do any value engineering. We sort of looked at common off-the-shelf products. So there's probably room to further engineer this and come up with better solutions, but we were modeling so many different archetypes that it really just, let's find some common things and see if it works. The one thing I want to bring to your attention in Nova Scotia is we replaced table 936.88. There was an error that was found to be in it. There will be an addition out later this year, probably December, January, in the NECB to correct that table. We've put the corrected table in already. And this might be a little bit outdated because I was talking to NRC yesterday after I brought the slide in, but a common question is in the NECB, why is Part 9 reserved? Well, this was the area where alterations to existing buildings were going to go into. However, right now, they're out consulting on greenhouse gas reduction and a whole bunch of other things. So there may be some renumbering in Part 9, 10, might even be a new Part 11, etc. But initially, alterations to existing buildings were to go there, and in the National Building Codes, it will be a new Part 10. So some of the significant changes, one is the application of the code, and I'm going to get into that because it's going to affect everybody. And this is all NECB for the most part. Building envelope, and I don't know whether Ann's going to touch on it, but we've had a lot of discussions. Airtightness in the NECB is probably the greatest opportunity / challenge, if you want to phrase it right. And there are changes to lighting, HVAC, service water heating. But I really want to dig into the application because up until the 2020 code, the NECB only applied to new buildings. So when you built a building to the NECB, on your next upgrade or retrofit, you could actually undo what you already did. There was nothing in the code that stopped you from putting in crappier windows or less performing air handling units, etc. But now the NECB is intended to apply to alterations. And it's worded kind of uniquely, but it was mostly designed because of a lot of times builders will build shell buildings, they'll build a strip mall, but they don't know who's going in it. And then engineers and architects were saying, well, this is an existing building, even though it's a brand new restaurant that's never been occupied. So the NECB doesn't apply to us. So now the NECB will. I've always said the NECB did apply to those buildings, but it's a little clearer with the way it's worded. So that issue is definitely covered. We've looked at it and got legal advice, and going forward, it is going to be our interpretation and how we are going to teach it to building officials. That buildings constructed to a version of the NECB, whether it's 11, 15, 17, 2020, must continue to at least meet the version it was constructed to. So you cannot undo what you originally built the building to. So if your windows were required to have a U value of X, if you replace them, they still require to have a U value of X or better. This probably will become less problematic in 2025 because there's a lot of work on alterations to existing buildings going on, and it is prioritizing energy efficiency for those buildings. And for those of you who are interested, there is a proposed change 1839 that's currently out for public review now, and that's one of the first steps regarding having the application of the NECB applied to existing buildings. I mentioned the public reviews going on, and there is a total of 10 provisions related to the NECB out. This review closes on December 18, and the link is there for you if you wish to review them and comment on them. And that's all I have, and I will turn it over to Anna. Maybe we'll take questions at the end.
Yeah. overview of the code itself and how it's going to roll out. So my half is going to be more about performance path implications of the changes. For folks that lots of folks in this room, but if you don't know me, my name is Anne. I work at AEECE. I was previously at Efficiency Nova Scotia, so you might know me from there. And I do love NECBs. I really like talking about it. So thank you, Justin and the team, for the opportunity. But genuinely, it's important for us to have standards, right? Because that is how we are progressing buildings, new buildings. Going back to Kevin's talk about setting targets for net zero buildings in 2030, which is not that far off. We need standards to follow to get there, because net zero is a very abstract concept, right? So having a guideline like the NECB is really important. NECB, of course, is very imperfect, but it's what we have, right? So right now it's not going away. It's not going to go away at least for another few years. So we're going to talk about what changed. I guess let's do a little poll. How many of you have looked at the changes proposed in the new code? I'm just going to try and move that lower. Okay, 5% of the crowd, maybe. Okay, so if you did look at what changed, you'll see that there's kind of little things here and there throughout, but some of the big things that changed, envelope performance, there's been some improvements in the minimum standard. Air tightness is a big one, lighting power density, very random changes in lighting power density, but it will have an impact, especially in buildings like schools and offices. Minimum boiler efficiency, and minimum COP for heat pumps, those two are kind of a big deal when we're looking at performance path modeling, and of course the performance tiers that Joe was talking about. So these are the tiers. Tier 1, like Joe said, this is kind of the baseline. So this allows us to still use the prescriptive compliance path. Technically, I personally, based on the work that we've done, we see that most buildings that are being designed in Nova Scotia are not eligible for prescriptive path compliance due to the envelope failure unless they use the trade-off path. After tier 1, so tiers 2, 3, and 4, we can only have compliance via the performance path, which is the energy modeling path. And the savings are 25, 50, and 60% versus the new baseline. Joe had said an average of 10% change. Sorry, I was going to say 5%. And I guess the reason for that is thinking about, this is specifically for Nova Scotia. So right now in Nova Scotia, most of our new building stock is housing, commercial buildings, when we look at the kind of square footage, right? Based on the modeling that we've done for high-rise apartments or mid-rise apartments, whatever, there is some change in what that baseline looks like under NECB 2020, largely because of the changes in minimum boiler efficiency and minimum heat pump COP. And I'll go over those numbers later, but essentially the baseline has become more efficient. Under NECB 2017, if we looked at a high-rise apartment, we would expect to see an EUI of 17 kilowatt hours per square foot. Under NECB 2020, that's going to be 15 or 16. And it varies based on the building, but that's kind of what we're seeing, is that the baseline has gotten a little bit more challenging, and then so that makes all of these, so when we look at the other tiers, then we're really looking at 30%, 55%, and 65% versus what we're doing right now. Again, as Joe said, these are the proposed dates for when these are coming into effect. Personally, I kind of like these because it's it's easy to remember. Every 2 years we get a shift, right? We can prepare. It's so helpful for the industry to have advanced knowledge of when a code is changing. This is a new thing for Nova Scotia as well. In the past, when we have a new energy code, it's usually been a couple months notice for the industry when a new code is coming. But if we know today that most likely in January 2028, we will be looking at tier 3, then that really helps us plan buildings that are going to be applying for permit in 2028. So some of the changes that are going to impact us the most. Like I said, there's lots of little changes, but there's some big ones that are going to have a big impact, and air tightness is the biggest, I think, anyway. What we have in NECB 2020 is a maximum prescribed envelope infiltration. So previously we didn't really have anything for NECB, or for buildings falling under NECB, so for 3 buildings. There were little requirements here and there around parts of the assembly that in theory had to meet certain performance, but no one was checking. Now we have this, and for folks who are doing energy modeling, you would know when we are using performance path under NECB 2017, we did have this number that we would use in models. That number doesn't mean anything, it's just the NECB gave us that number because we had to have something, like you can't just have no infiltration in an energy model because that doesn't make sense. So we had that figure, but now we are using, I don't know if this is a pointer and I'm not gonna try it. Now we're using that top one, so 1.5 liters per second at 75 pascals. So we need to, when we are modeling, we need to bring that down to 5 pascals, find the equivalent infiltration at 5 pascals. They give us a formula to do that. Lovely, folks are probably familiar with that formula if they've done work with CAGVC, because they also use that formula. So the interesting thing about this approach is that it gives a different prescribed value for each building. So this is essentially what that formula looks like when you're just using the default. So if you're working on a project that is not planning on getting air tightness test, you're just going to use the default air infiltration values, and those numbers here, of course, are going to change for each project, and essentially it kind of becomes based on massing, right? So if you have a building that is low and has a lot of roof area, your total envelope area is going to be much higher than your above grade wall area. And so those are some examples right here. If we have a warehouse, we might have a value like 1.4 liters per second meter squared at 5 pascals. If we have an apartment building, it's going to be like 0.43. So those are 2 very different values, and in the model that will do very different things to the results. That warehouse number, like that is significantly larger than the 0.25 we were using before, right? So if we modeled that warehouse under NECB 2017, we would be using 0.25. If we model that warehouse under NECB 2020, we're going to use 1.4 for infiltration. So that is, essentially that is making the building's heating load go way up, right? And here I just made some nice little figures for you guys to remember, right? So if you have one like this, your baseline infiltration rate should be low. If you have one that looks like this, it should be high. If it's not, maybe check again. And the formula itself is, I looked back in the NECB several times because I'm like, are you sure that this is what we're supposed to do, right? Like, are you sure we need to like put all the total envelope area on the numerator? But in several places, that is how the code is defined, that formula. So yeah, when we have low-rise buildings like this, we can see really high infiltration rates, which changes the results. The proposed rate, so we can either make the same as a baseline, so we use the same infiltration rate in both. If the building is going to be tested, we can use an estimated infiltration rate in the proposed. So this is where, and Joe mentioned like the opportunity associated with air tightness. So under previous codes, we could not include savings achieved from airtight construction. Now we can if the building will be tested. As modelers, we have to then figure out an estimated air leakage, which will be an interesting exercise because we have no data currently. We have minimal data. But at the model stage, we would make an estimate, and then when the building is constructed, the building would need to be tested using whole building air tightness testing. And then it should align with what the model is, be equal to or better than what we assumed in the model. If it's not, well, then we just need to make sure the building is still going to pass. And this isn't new, this happens in British Columbia, this is part of their code, so this industry is possible, it's just we don't do that here yet, so it will be a change. essentially this is just what I just said. So if we have higher infiltration in the model, then the heating load is going to be higher. So even if we don't include an estimate of the measured rate, so say we have the same infiltration in the baseline and the proposed model, we're gonna get more energy savings from an efficient HVAC system, because you put more load on both sides, the amount of savings goes up. But really what the advantage is actually promoting the uptake of airtight construction, because now we can claim it, right? So there's actually a bit more like a business case for pursuing those measures in a project because it makes sense, but of course the building must be tested. And when we're thinking about the size and scale of buildings that are planned for Nova Scotia, we are likely going to need some bigger fans. I don't know if ThermalWise is here today, but I know they know this is coming, as do the other hopefully other testing organizations in Nova Scotia. But testing a 30-story tower is a little different than testing, a 4-bedroom house, right? So, but it can be done. This is done in other jurisdictions. We just need to build that industry here to make that this opportunity available. Other key things, so going back in NECB 2017, when we are modeling under performance path, our baseline COP, we have air source heat pumps in the baseline, the COP is 3.1, the boiler efficiency was 0.83 or 83%, for adjusted hot water heaters it was 80%. So now our baseline COP is 3.3. Boiler efficiency is 0.9. So these two things, they do make a big difference. They're just less of a gap, particularly on the fuel side. So when we model fuel heated buildings under NECB 2017, we're essentially getting quite a lot of free savings right now because everybody's using condensing gas boilers. 95% efficient. When we compare that to 0.83 in the baseline, we were getting a lot of what I think is kind of free savings because no one is installing a boiler that's 83% efficient today. Well, no, that's not true. Some people are, but it is not common. 0.9 makes a lot more sense as a baseline. Heat pumps, sure, this is representative. It just means that the amount of savings that we could get from good heat pumps is now lower. And then same thing on domestic hot water, we've gone to 0.9, which again is representative of the market. So, and Joe kind of made a reference to this as well. When we are defining our reference building or our baseline, we follow tables 8.4.4.7 and section 8.4.4.13, which is the heat pump section. Neither of those changed significantly. I think one of them maybe had a little note that changed, which is unfortunate because it is the worst part of the code. We have a double standard, right? Standard 1 for buildings that have heat pumps and standard 2 for buildings that don't. And it just makes things awkward and not confusing, it's generally well laid out, but it's just that we're not looking at all buildings the same, right? So these haven't changed. If you want them to change, maybe make some comments on the current public consultation that's open. Maybe in the 2025 codes, we'll see that change. And also just a note for folks, if you are new to codes, when we're talking about 2025 codes, that does not mean they're coming in 2025, right? Just so we're all clear on that. So if you make a comment on those public consultations that are open now, we'll probably see that in 3 years, maybe. Envelope thermal performance, there was a slight change, minimal in the maximum U values. For the baseline, we're still using the same thermal bridging calculation method. So if you've seen that formula, that's still around. This is my favorite part of the code, just super interesting stuff. Building envelope thermal bridging guide, of course, is the resource for thermal bridging. So it's still super important, and those values prescribed, so the maximum U values or the minimum R values, are still mostly not achievable for our buildings, unless we start putting a lot more exterior insulation on buildings, especially buildings with windows. So what does this mean for our projects in our province? and sorry for folks from New Brunswick and PEI, I just don't know your buildings as well. So tier 1, like Joe said, is achievable with most of our current practices. Tier 2 is achievable with some of our current practices. Tier 2s and above, we of course will need an increased uptake of energy modeling. I personally believe like the resources there, like the modeling community can certainly handle the work. It's more like change on the project side. So folks running projects, not only the owner but the rest of the team, needs to get used to the idea that energy modeling is going to be in the project. Because right now it's still, it still kind of is an afterthought for a lot of projects. So that would need to change. Tier 3, so that's 50% is achievable if we're doing energy optimization assessments. And I think tier 3 is this is true without huge incremental costs. So that's where energy optimization is important. Like, it doesn't have to cost a ton to get to tier 3. It can, but it doesn't have to if we are doing energy optimization. Tier 4, 60% is challenging. Certainly achievable, especially if we are looking at including airtightness savings. So, if we're looking at, and I've had some conversations with folks in industry about, can we do this, right? Like, these are new standards, things are getting more challenging, can we do this? And as a province, like, we're actually doing pretty good, especially on heat pumps, right? When we look outside of Nova Scotia, looking at Ontario, Toronto, there's still a lot of buildings that are using like four pipe fan coil systems with gas boilers because gas is so cheap. Like, why would you not? And similarly, in other jurisdictions, energy recovery ventilation is not as common. So a lot of places are just using, like, say if it's a multi-unit building, a high-rise apartment, which I work on a lot of those, so I know those well. There's a lot of central systems still, just central makeup, feeding into apartments, no recovery. So we here are doing really well on energy recovery ventilation, not just in apartments, but in all types of buildings. Lighting, of course, LEDs are, like, why would you not? We're also doing pretty well on insulation. We're just not always putting it in the right place. And we're doing well with using punch windows, which is like vinyl windows instead of metal frame windows. They lose a lot less heat around the frame. Some things we need to work on, reducing our thermal bridging, maybe not using as much curtain wall, or like not at all, or if we're gonna use it, like, we gotta put something behind it, because it's kind of like building, it's our value is basically equivalent to cardboard, is how I think about curtain wall. Glazing ratio in some buildings will need to come down. We have a relatively low uptake of geothermal in Nova Scotia, and similarly with air-to-water heat pumps. So, and air-to-water heat pumps here, both for space heating and domestic hot water heating. So another thing, I'm not sure how we're doing for time. I'll talk fast. So just some things, like trying to make this a little bit more like, okay, but what does this actually mean if we're designing a building? So for tier 2, so to get to 25% savings, FTWR, that's our glazing ratio, window wall ratio. So we want to have less than 50% glazing. 50% glazing is like a lot. That's like 50% glazing, we would see that in high-rise office buildings or some multi-units, those type of buildings. Most projects like schools or hotels, retail, like, they don't usually have that, so that's not a problem. ERVs, we should really be looking at least 70% recovery on any system. Heat pumps, same thing, like, only using heat pumps that have decent low ambient and a COP above 3.5. So I guess just on this list here, it's a short list because tier 2 shouldn't be that challenging for most projects, right? It's just a matter of like looking at the options. So for tier 3, getting to 50% is hard, especially if we're not including air tightness. So of the projects that I've worked on, I've seen like above, say, NECB 2017, maybe 3 that have achieved 50% savings above NECB 2017. And usually that's, there's a reason, because they're pursuing some other standard like LEED or CAGBC zero carbon or whatever. So it is a hard target. So we need to say, bring that glazing ratio down, especially in multi-units. Oh, okay, I really have to talk fast then. Actually considering thermal breaks, easiest way to do that is having continuous exterior insulation that goes bypasses the floor slab. High performance glazing, so in buildings that have a lot of glass, like we're gonna start seeing folks getting into like vacuum insulated glass, which those windows have an R value of like R12. It's like a wall. They're just really expensive. Airtight construction, of course, is going to help us get to tier 3. And then again, we get into ERVs. Thank you. We can bump it up again to 75% on the sensible side. And then heat pumps, we should really be looking at heat pumps with a rated COP above 4 and really low ambient. And then air water heat pumps for domestic hot water. This is in order of envelope to HVAC. Because we really do need to have more focus on the envelope design when we are looking at trying to get to tier 3. And that's what that says. So reducing the building's heating load compared to the baseline, right? Like we need to do that. Right now, we're not always doing that. We're just talking about HVAC still. So we need to reduce the building's heating load. We also need to be using more integrated design, having everyone at the table, talking about the project, talking about its goals, how to get there, as well as parametric energy modeling. So looking at different, assessing different combinations of measures using energy modeling. Those are the same things that I just said for tier 3. They're just in nice bubbles for you. But also that these are all achievable. So this doesn't mean we have to go and like invent something new or whatever. These are things that we have in our market today. Some of them are more expensive than others, but these are things in our market today. And it doesn't, depending on which things a project chooses, it doesn't have to mean the project cost is going to go up by 30%, right? Like low glazing ratio, that's actually cost savings, right? Great. Insulation, if you just move it to the other side of the stud wall, it doesn't have to cost more. It's just planning. Same thing with airtight construction. A lot of buildings are already doing that. They're just not testing, right? That one, yeah, that is expensive. It's just that, some buildings will need it, others won't. Hopefully it gets cheaper. Heat pumps, it doesn't have to be more expensive to get a better heat pump, right? Often we do see that, and folks who work in the sales side would be able to confirm, like, it doesn't have to be an increased cost. And costs are always changing. Okay, that's the end. Yeah, if you didn't care about the NECB before, you should now, because it is, it's going to affect all our projects. Do we want to do questions? Where are we at?
Yeah.
Okay.
I think we have a few minutes of time. Yeah. So thanks, Ann and Joe. I think what we all took from that is that this transition is going to be really easy. That's what we all took from it. So great, thank you. No, we're definitely all going to have to up our game. But thanks for presenting that information. Any questions?
So you have Sparky in the room. I'm sorry, my question is going to be about electrical. I know that was all wonderful, wonderful energy stuff. So NECB changes, I've noticed we often base on ASHRAE versions, like ASHRAE 90.1 for lighting and electrical. And in 2010, ASHRAE proposed we started controlling receptacles so that half of them or some of them turn off in an office building after 20 minutes of vacancy. And that we have been passing that up. NECB just doesn't include that bit. So I'm wondering if we are going to continue basing our NECB, other than the tiers, but like all the other bits, like lighting controls and controlled receptacles and all those other bits that aren't based on a percentage improvement. Are we going to continue following ASHRAE, or are we going to go on our own path and stay with this? I think it's ASHRAE 2017 that both our 2017 and our 2020 are based on.
That's a good question. But that's certainly that's things that the Standing Committee on Energy Efficiency are looking on. You know, the general policy direction is we want to improve energy efficiency, you know, which is why the tiers were developed. But the how we get there is being left with the technical experts that all sit on the Standing Committee on Energy Efficiency. If you have any recommendations, I encourage you, their meetings are public, I encourage you to attend them. As an observer, you can certainly offer input at the chair's discretion. I'm not aware of anybody who has ever attended a meeting that's been told, no, they can't speak. So, you know, I'm not an electrical guru either. And so, you know, that's all I can encourage you to do if you know, those type of things are important to you.
I think generally too, yes, the code will always, like, NECB will likely continue to look towards ASHRAE, whether that, you know, is actually brought into the code or not is more at the discretion of the folks on the steering committees and whichever else, but ASHRAE and ASHRAE's guidelines will continue to be like a resource because, you know, it's ASHRAE, so.
Great. Any more questions?
I think Chantal had one.
I'll have time for one more after.
Hi, everybody. My question is about air infiltration. What are your thoughts on how that plays out when a building has chosen air infiltration as a means to meet a tier that is code and the tests don't come back as intended?
So I think, and this of course happens in other jurisdictions where this is already a requirement. So in British Columbia, parts of British Columbia, what I understand is that they have an opportunity to essentially go back, try and fix it, and then get it retested. Or the building would have to pursue other measures to meet. So if it's actually, you know, if the performance requirement is 50% savings and it's modeled at, you know, 53%, they go to the test and then turns out they only achieve 48%, they can either go back and, yeah, improve the infiltration, so go in, you know, do the same thing that people do in houses, right? Like seal around the windows or whatever, and then have it retested, or they can go and change other things in the building. So maybe they change light fixtures, put in occupancy sensors or something to balance out the losses on what they were expecting to achieve with their air tightness. But I mean, so my understanding, I guess, on the permit side is that they would have the opportunity. The same thing that happens now with a building that, you know, you have an inspection, it doesn't pass the inspection, they go fix it, it gets re-inspected. So I think we would see that happen, yeah, with the energy code as well. If that makes sense.
Aero barrier.
Yeah, exactly. Get air barrier, though that can be challenging if it's already been drywalled. Because, you know, it can be fixed, it's just expensive and time consuming.
Thanks. One more question?
Yeah, Nick.
Nick Strong, Consulting. And on that infiltration topic, are there any curtain wall manufacturers or providers that give guarantees of infiltration?
That give their values.
Yeah, or you know, you see that on paper, but how reliable is that? And then when it doesn't pass, you know, who does that go back to?
That's a good
I'm
question.
just curious, you know, because that's what's going to come up.
Yeah, and honestly, I'm hoping that this kind of puts pressure on the curtain wall manufacturers, because curtain wall manufacturing challenges or, you know, errors are a big source of infiltration in buildings. Like, we know that now without having the testing done, just from, you know, anecdotal evidence. So, you know, I think, yeah, it would be nice as modelers if we could get, you know, a value from the curtain wall manufacturer. Though we also know that that's not going to be representative of the constructed building, because it's dependent on how it's been installed, you know, what's done at, say, the junction between the curtain wall and the rest of the building, whatever. But yeah, absolutely, hopefully we will start getting those the same way that, you know, we've been pressuring curtain wall manufacturers to provide their effective, you know, thermal resistance value for the assembly instead of just a center of glass value, and they've shown up and started doing that. So if there's a demand for it, then hopefully, yeah, we'll see that.
Thank you.
Great. Great, thanks, Ann and Joe.